Okay, let's look at how to solve systems of inequalities. So we solve systems of inequalities by graphing it. Make sure your computer is closed. And then we look at where the shaded portion is. I'm going to change one of these though. I'm going to change that second one to start with. So go ahead and change it to y is greater than negative 3x plus 4. All right, so in order to graph it, they both need to be in y equals mx plus b. Just like whenever we graph a system, we find out their intersection, we make their lines. But with inequalities, we're going to add that extra step of shading because it has less than or greater than involved. So let's go ahead and do the first one. So here's our m, here's our b. When we graph, we always start with the y-intercept, which is the b. Here's our y-axis. Here's our x-axis. So we are going to plot our y-intercept at negative 3. And then do our slope. If our slope is 1 over 2, that means I'm going to go up 1, right 2. And I'm going to make all the pretty points. Rise 1, run 2. Rise 1, run 2. And then do the complete opposite. Go back down to your y-intercept and go down 1, left 2 to make the other points that we can connect to make a line. Bless you. Okay, and then we've got to do our line. So we look at the inequality, so less than or equal to means it's going to be a solid line because of the or equal to. And the less than means we're going to shade below. So it's solid and below. So use a straight edge. You can use your ID to connect to make your line. And we want to shade below. So look at where your y-intercept is. So it's right here. And now shade below. Okay, let's go to the second equation. Y is greater than negative 3x plus 4. So this is our m, this is our b. Plot your y-intercept, which is 4. So go to 4 on your y-axis. Then we need to do our slope. Our slope is negative 3, but you have to have a denominator, so it's going to be over 1. It's that invisible 1. So we are going to go down 3 and right 1. Always go right. The negative goes with the top number, which means we're going to go down. So we started our y-intercept, count 1, 2, 3, down, 1, right to get a point. Keep on doing that. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. I can't go down anymore. Now go back to your y-intercept and do the complete opposite. Up 3, left 1. So the second equation has the inequality that looks like this. It's a greater than symbol. So remember, left hand makes a less than. This one's the opposite. It's flipping your left hand over, so it's greater than. So this is going to be dashed and greater, wouldn't it be above? Above. So get your straight edge again. Draw yourself a dashed or dotted line. Then we need to shade above. So we go to our y-intercept. Here's our y-intercept. And then we shade above. So it's all of this area, all of it. There we go. So our solution is where the double shading happened. So point to that. Double shading equals solutions. So you don't just have one point that's included in the solution. It's every point. So you could put a point right there. Put a point right here. Anything that's on the line, like a solid line, or in the shaded area. So this solid line is included, but not the dash line. Anything on the dash line is not included. So, solid line equals solutions. But not all the solid line, just in this area right here. The solid line, and then anything in the double shaded area. Just from here to here. Okay, let's go to the next one. Example 2. It says, write the system of inequalities from the graph. So we've got to write each equation and then write the inequality that goes with it. So let's start with the horizontal line. Let's find out what its y-intercept is. It has a 0 slope, so it's going to be y something negative 2. Was it shaded below or was it shaded above? Greater than. Because there's no shading below that dotted line. So it's going to be greater than. And it's a dashed line, so it's not what we're equal to. So that means that this one was shaded above. Okay, let's look at the second one. Look at your y-intercept. It's at 2. So our b value on that one is 2. We've got to find our slope. So find another pretty point. Looks like that's a pretty point. So we know b equals 2. We've got to find m. Negative 4, so let me count. 1, 2, 3, 4 over 1. So negative 4 over 1, or just negative 4. So we're going to do mx plus b. So I'm going to leave the inequality. I'm not going to put equal. I'm going to put negative 4x plus 2. So we got to know how it was shaded. So look at your y-intercept. Did it shade above it or below it? Is there any shading up here? No. So it's shaded below. So it's less than. It's not or equal to, it's just less than. Okay, we can graph these in our calculator. We can graph it in Desmos. Desmos won't graph inequality. It won't graph the shading, but it'll graph the lines so you can see their intersection point. Okay, example 3. It says, name 3 points that are in the solution set for example 1. So any 3 points that are in this double shaded area. So I'm going to go 1, 2, 3, 4, -2. That is that point right there. That's in orange. And then we could do any point in here. So there's more than one answer. We could do 5, -4. I need one more point. What is it? 2, -1, 2, 3, 4, 5, 6. No. What else? Yeah. 1, 2, 3, 4. Is that it? 2, 4, 6, -1, 2, 3, 4. Yeah. 6, -4. Yeah, that'll work. And it could be on the dotted line as well. I mean, the solid line. Sorry. Okay, the next problem. We want to decorate a party hall with a total of at least 10 red balloons and yellow balloons, with a minimum of 5 yellow balloons. Write a system of inequalities to model the number of red and yellow balloons we can buy. So let's just think about it. Not even mathematically. Let's just think about it. We want to decorate with a total of at least 10. So how many could we have if I say at least 10?
11.
Huh? 11. What else? 10. What else? How many could I have if I have at least 10? Give me one more. 15. Yes. Not 9 because it says at least. So that means it's 10 or more. Okay. But we want a minimum of 5 balloons. So that's a stipulation. All right. So what if we have 5 balloons? We have 10 total. How many red balloons would we have? 5. So as long as they add up together to be 10 and you have at least 5, then those would be solutions. So now we'll write it mathematically. So let's see. So at least 10 with red and yellow. So let's do this. R equals red balloons. Y equals yellow balloons. So we need to write an equation that represents at least 10 total between red and yellow. So red plus yellow is something 10. At least, what does that mean? Greater than or equal to. Okay, and then it says a minimum of 5 yellow. So how can we write a minimum of 5 yellow? Y and 5, right? Minimum means at least, so that's greater than or equal to? Yeah. Okay, so we've got to graph this. So it needs to be in y equals form. So I'm actually going to change red balloons to X. Just because I need to have X and Y so I can graph it. This graph, it's not going to work because it needs to go up to 10. So you can either go by 2's and graph it, or we can redraw the graph. I think I'm going to go by 2's. Okay, so if it says y is greater than or equal to 5, I need to go to 5. So I'm going to go 2 by 2's. 2, 4, 5. Draw yourself a horizontal line for y is greater than or equal to 5. Okay, so we want to shade that greater than, so greater than means above. So shade this above. Okay, we need to do the other one now. So this is x plus y is greater than or equal to 10. I need to get y by itself. So x is on the wrong side. So how do I move x? Subtract it. And I want mx plus b, so greater than or equal to negative x plus 10. We're going to graph this. So remember, you graph starting with your b. Remember, going by 2. So 2, 4, 6, 8, 10. Plot a point, because I'm going by 2's on the y-axis. And then we need a slope of negative 1 over 1. So we're going by 2's on the x-axis too. So down 1, right 1 would kind of be in the middle. Down 1, right 1 again would be at the next pretty point. So we can just go down 1, right 1. We're going by 2's, so I'm really going down 2, right 2. Okay, this one does say greater than or equal to, so we are going to draw a solid line. And then how are we going to shade? What does this mean? Oh, hold on, I'm on the wrong one. Let's try that again. How are we going to shade this? Greater than or equal to? Above. So anything in that double shaded area would be our solution. So what is a possible number of red and yellow balloons that would fit this criteria? Okay, so 2, 4, 6, 8. Did you say 8? And 2, 4. Front. Yeah, so it wouldn't work. 5 yellow, 5 red would work. What if I have 3 red? What would be an option for the yellow? 7. Or couldn't I do 8? Because it could be more than 10 total. So let's say 3 red, I could do 15 yellow. As long as they add up to equal 10 and what? Yellow has a minimum of 5, we're good.